Independent and dependent events. Like I said, this is the last lesson of the chapter. We'll take a test next week. Taking good notes today is essential. It's important, so you know the difference between these two things. Okay. So first, we're going to talk about independent events and what they are. So independent events are right here. I'm going to move it up a little bit. There's the definition. There's a formula for you. And I'm going to do an example with you. Okay.
Wait, I feel like we've done this. Haven't we done something like this?
I think we've done parts of it, but I haven't. We've done parts of it. Yeah, like sample space.
Yeah.
We kind of did something with sample space with it. This is just another way of not making actual sample space tree to figure out some of these probabilities.
So it's basically the same thing.
A lot, but it's using math instead of like making a tree. Using math.
I feel like we use math for all of them.
You do.
Because you're teaching us math.
Oh dear. Independent events. The occurrence of one event does not affect the probability of the other. An example of this, an example of independent things would be like, I was going to do an experiment and spin a spinner and roll the dice. Do they have anything to do with each other? They have nothing to do with each other. Like if I spin one on my spinner, it's not going to have any effect on how I roll my dice. That's independent events, like two different things that are happening in an experiment. Okay. An example of that, if you want an example, here's an example. Okay. Let's say you're going to roll a number cube or a dice, and you're going to flip a heads or a tail. Okay. So if you have, let's see, what's my probability of flipping a heads? Okay, and rolling even on the dice. Okay, this is an example of independent events. So my probability of flipping heads on a quarter and then rolling even on a dice. So the first thing I'm going to do is I'm going to find my probability of flipping my heads. Half, right? Flipping heads, 1 out of 2 chance, 50%. So half. What's my probability of rolling even on the dice? Also have 3, 6, right? 3 out of 6. I'm reducing everything I'm going to reduce today. Okay? So even on the dice, it'd also be 1/2. Okay, this is like A, this is B. We're going to multiply these two things together. Multiplying factors, you remember you go across. So my probability of flipping heads and rolling even is 1/4. I have a 1/4 chance of rolling a dice and getting even. And flipping heads.
Going back to just multiplying.
Correct. Finding your probability, and then multiplying. That's going to give you your probability of you doing that thing at like back to back at the same time. Yeah.
Do we have to do like the part on top? Like the green?
The formula. This.
Yeah, we have to.
It's going to give this to you.
Oh.
You have to find this part.
Well, no. Do we have to like write that out too?
No, it's going to be written out for you, most likely.
Well,
It's going to be written out. Okay. All right. So let's try a dependent event then. Dependent events are right here. And I'll do an example of this with you also. right, so this time, it's when your event does affect your second thing. Okay, so here's an example of this. In my bag, can I move this? You guys care if I move this around a little bit? If I go like this, can I go like that?
Yeah.
Okay. So in my bag here, I have some beads. Okay. In my bag, I have red beads. I have blue. I have yellow. And I have green. And I'm going to tell you how many I have of each. The red I have 4. Blue I have 1, 2, 3. Yellow I think I had 7. And green I have 1, 2, 3, 4, 5, 6. Altogether, I should have 20 beads in here. Okay? So this is what it would say. It'd be the probability of choosing, let's see, a blue, then a green, and then without replacing. Okay? So in here, let's just talk about the blue. What's my probability of getting a blue?
3 out.
Okay, 3 out of 20. Let's say I pick that blue out. Oh, I actually did the experiment. I was lucky and got the blue. Okay? I'm going to keep them out. That's what I mean without replacing them. I'm not going to put them back in the bag. Now, what is my probability of getting a green?
6 out of 20.
No, it's not.
Oh, 6 out of 19.
6 out of 19. Because how many beads do I have in here? 19. I took my blue out. It's not in there anymore. Now I have 19 beads. So I have 6 green in there, but I have 19 beads inside of here. That's what I mean by what you do first. I kept it out. Depends on what happens the second time. That second time depends on what you pulled out that first. That's why there's 19 in there. If it would said replacing, then how many beads would I have in here? I have 20, right? So you have to watch the wording. Wording is really important. So now you got to multiply. You got to multiply across. You can reduce here. You can reduce 6 and 20. You can reduce by 2. So 2 goes into 6 3 times. This would be 10. And then I can multiply across. 3 times 3 would be 9. Be 190. Can I reduce there? I doubt it. So this will be my answer. So you see the difference between the two. Independent, you maybe have 2 different things going on. Rolling your dice in your spinner. Dependent, you maybe are picking out the same type of thing. Maybe it's beads, maybe it's people, maybe it's money, maybe it's, I don't know, sock drawer. Because if you take something out and you maybe don't put it back, that's going to change the number of what you have in the second. Other things I have for you to write down is some keywords. Sometimes there's keywords to go along with this stuff. So if you see one of these keywords, you can kind of determine like what kind of event it is. So independent event, look for these words or look for these things. 2 different things. Maybe it says is replaced. Maybe you pick a sock out of your drawer, you're going to replace it back in. It's going to tell you what's going on. Okay, dependent, if they say do not replace, or a lot of times like if it's like the same type of thing, like beads or socks or people, and it says at random, that too is a good thing to tell you they're not going to put it back. It's a good I don't know, keyword to tell you they're not going to put it back. All right, here's an example of another dependent event. Okay, if I said at random, I'm going to pick 2 kids in here. What's the probability that I get one with a black shirt and one with a green shirt? So in here, what's the probability of me getting a black shirt? 1. You got black on? 2, 3, 4. How many? What do you want to be counted as green or black? Okay, so 1, 2, 3, 4, 5. So 5 out of how many? Okay. Let's say I did. Let's say I picked foot and out. You got black on. Okay. What's my probability of me picking a green shirt?
1 in
2 out of 2. 2 out of no.
8.
2 out of 8. I at random is picking people. If I say I at random pick 2 people, I'm not going to put it back in the group. So this would be
536.
what? That is it reduced. 10 over, actually you can probably do some reducing here too. 10 over 72 divided by 2, 5 over 36. That's the possibilities I have of picking a person with a black shirt and a green shirt. Okay? Are you guys kind of seeing the difference between the two things? Like, it's hard to see the difference. You have to pay attention to your weight. All right, so let's practice this. Tell me if it's independent or dependent event. You don't have to write it down. Let's just talk about it. The first one says, you select a marble, you don't replace, you select another marble.
Dependent says you
What do you think?
Dependent says you do not.
You don't replace, you don't put it back. So that's going to change how many marbles you have that second time, right? If I have 10 marbles in there, I pick one out, I'm not putting it back, how many do I have? I have 9. So, yep, dependent. Roll a dice, then roll it again.
Dependent.
And because it's at random.
No, but it's independent because if I roll my dice, is that going to affect what I get on my second dice?
No.
No, it has no effect what I get second.
Yeah.
Right, you can't take numbers off, and that's what I said in my other class, I can't take a number off. So this is independent, because even though it's the same type of thing, I'm doing 2 different things and I can't change it. Drawing a number, I'm replacing, and drawing again, independent, because I'm replacing it and putting it back. Getting one gumball out of the machine, then getting another gumball out of the machine. Dependent, because you took a gumball out, I changed how many gumballs are in that thing now. Right? Flipping a coin, rolling a dice, independent, because there's 2 different things going on. And what I do with my coin doesn't affect what happens on my dice. Okay? So you gotta pay attention to what you're doing today. All right, I think I talked about like this. I like to go to, let's talk about this one. Okay, this is another dependent event if you're kind of confused about that. Dependent, so you have 7 cards, 2 green, 4 red, 1 blue. 2 cards are drawn, they're not replaced. What's the probability of picking a red and then a blue? So first of all, what's my probability of picking a red?
4
Out of 7. Okay. I take out a red, I don't put it back. What's my probability of picking a blue? 1 out of 6. Multiply across, I get 4 out of 42. I can reduce by 2. 2 out of 20. 21. Yep. I could reduce here first if I wanted to. That would have been easy too. Let's go to this one. I'm probably only going to do the top ones because we replace it first. What is this? When we pick 2 cards, okay, I'm replace it first. What's the probability to pick a green and then a blue? So I'm replacing, I'm putting it back. So what's my probability I'm going to pick a green?
1 out of 6.
Okay. Now I pick my green and I put it back. What's my probability of me picking a blue now?
2 out of 6.
2 out of 6. I can reduce if I want to. I can reduce. That's right. Goes in 1 time, goes in 3 times. 1, 18. Okay. You pick 2 cards and do not replace the first one. What's the probability of picking yellow and then a red? So yellow would be 1 of 6. I'm not putting it back. And then it would be a what? 2 out of 5. Multiply across, I can reduce. 115. Okay. Any questions so far? I have a few more because they're just a little different style. Find the probability. Oh, no, I'm going to make one up. Okay. Rolling. On the dice. And picking a consonant. What's that again?
A-I-O-U.
No.
No, not A-I-O-U.
The out of the word. That's what I was gonna do.
It's
Constants are anything but the vowel. So that's it. So, right, so let's go back to rolling the odd on the dice. What's the odd? What's the probability of rolling an odd? Half, 3 out of 6, right? So half. Now, what's my probability of picking a consonant out of the word math? 3 out of 4. Multiply across, 3. There's one like this on your homework today. Okay? One or two. It is easy, but you've learned this stuff already. You like learn how to find the probability. Now we're just putting it together, that's all. And then you have to remember if it's independent, if it's replaced or not. Yep, you gotta think about that. Today's homework, that's quick, that's fast. We've actually learned that. That's all I have.